Hi everybody, welcome back. So this is Algebra 1 in week 3. We're going to continue with section 5.6 and actually use this week to wrap it up. So as you can see from the title, and I'll zoom in so you can really see here. Zoom in. This is going to be a guided review. I'm going to walk you through how to do all of these problems, and I will provide you an interactive worksheet that is pretty much the exact same format as what I'm doing here, just different questions. So you'll have a worksheet just the same as me. You'll have these text boxes where it says click here to type work and answer. If you're confused on how to do those problems, refer back to this video, rewatch, and use it as a guide. So the review that I will give you, which will say independent review as opposed to guided, your review will be due Wednesday. And then on Friday, I will post another interactive worksheet, which will look kind of like this, but will be shorter. It'll say 5.6 quiz. It'll have 6 questions, and the quiz will be due the evening of Friday. Okay, I'll try and get that posted before Friday though, so that way you've got a little bit of time to work on it. So let's go ahead and get started. So the way that I've broken down this review, everything on page 1 has to do with lines that will be parallel. And everything on page 2, the worksheet generator that I use abbreviates the word perpendicular to perp, but that's what it stands for. It stands for perpendicular. So that's what section 5.6 is all about, parallel and perpendicular. So a few things to keep in mind. If you're trying to find the equation of a line that's parallel, you want the same slope, okay? So the first thing we need to do is we need to look at this given equation, because that's what I want my line to be parallel to. And I want to determine the slope. Well, my slope is this, -9/2. So I know that whatever I do here, my slope has to be -9/2. Now I need to look and see what form do I want my equation in. Well, it says I need to write my equation in point-slope form. Point-slope form is the following: y minus y1 equals m parentheses x minus x1. It's my opinion that point-slope form is the easiest way to write your equation, because once you've got your slope and a point, you just plug everything in and you're done. So that's what I'm going to do. I'm going to start by writing my equation, y minus, but instead of y1, I'm going to put the y value from that ordered pair, which is 5, equals, but instead of m, I'm going to use my parallel slope, which has to be the same slope as the original equation. Open parentheses, x minus, but instead of writing x1, I'm going to write the x term from that ordered pair, which is -2. The only thing I can do in this next step is simplify these double negatives. So it should read y minus 5 equals -9/2 x plus 2. And that's where I want to stop. This is my final answer right here. You don't want to distribute. You don't want to get the y by itself. This is in point-slope form. I'm done. Let's do the next one. It needs to pass through this point and parallel to this equation. So same thing. If it's parallel, I know I need the same slope. Well, as you can see, there's only a minus sign in front of this x. The thing that's touching the x is always your slope. This is in slope-intercept form. If you don't see a number, it's understood to be a 1. Please don't write that your slope is -x. That's not correct. Your slope is never a variable. It's always a number. My slope is -1 in this case. And same thing as last time, I want my equation to be in point-slope form. Well, it's going to be y minus y1 equals m parentheses x minus x1. That's the form and everything that I need. I'll start by substituting all of the appropriate numbers in the appropriate places. Y minus, my y value is -1, so I type that in, equals, my slope is -1, so I type that, open parentheses, x minus, and my x value is 2. Last but not least, I've got a couple double negatives I can simplify to a plus sign. Y plus 1 equals -1, x minus 2. And again, you could have just written negative and then your parentheses if you wanted to, but you definitely need the parentheses in this case because there's a negative sign. So I guess I'll put that off to the side. or y plus 1 equals negative x minus 2. Either of those would be appropriate. You don't have to list both if you get something like this as an answer. Just give me one of them. All right, moving on. These are all still parallel, as you can see. Parallel, parallel, parallel. All of these are parallel. It's just the form that's changing. Now I want my equation in slope-intercept form. Well, what's slope-intercept form? Y equals mx plus b. And same as before, I want the same slope. But before I do that, look at the type of equation I'm giving you. I almost don't need any form for this. Look at what type of line this is. What kind of line is x equals a number? It's a vertical line. So what's going to be parallel to a vertical line? If you go back to your notes where we reviewed that, it's going to be another vertical line. So I need x equals a different number, and specifically it has to be x equals 4. Okay, so just a reminder, a vertical line will be parallel to another vertical line. So I need x equals 4, and this is actually my final answer. It said to put it in this form, but vertical lines and horizontal lines don't really have a form. It's either going to be x equals a number or y equals a number. Final answer, and I stop there. We're not going to get so lucky for this one. We're going to have to do a little bit of work. It's not a vertical and it's not a horizontal. I have both a y and an x, but I still want it in slope-intercept form. So I'm going to write my form, y equals mx plus b, and because it has to be parallel, I need to use the same slope. So the slope that I need to use for my equation is 9/2. Okay, m equals 9/2. Now, if you recall, slope-intercept is the one where we first need to solve for the b value by taking this form and replacing all the first 3 variables with numbers and then solving for b. So do you see this -4, our y-intercept in the original equation? We ignore this. We do not use this y-intercept. We're solving for a very specific y-intercept. So in my next line of work, what I'm going to do is I'm going to replace the y with the y value in the ordered pair, the m with the 9/2, which we're using for our slope, and the x with the 2. Now, notice that these 2 variables are touching. That means multiplication. So I'm going to have to utilize parentheses or some sort of multiplication symbol to show that these 2 things are being multiplied. It looks a little weird because I'm typing it all out. Normally, if I was writing this, I would write it with a horizontal fraction bar, and the fraction would look more vertical. But if you're using a calculator and you're good at doing fractions in a calculator, you should get the right product. You should get that when you multiply 9/2 with 2, the 2's cancel and you just get 9. I still have my plus b. I want to solve for this. In order to solve, I got to get rid of this 9 on both sides. It's obviously going to be an addition or subtraction step. To figure out if you add or subtract, don't look at this sign. Look at the sign in front of the 9. If there isn't one, it's positive. That means I do the opposite and subtract. Do it to both sides. These are going to cancel. If you want to get real fancy, you can draw a little line through it. You don't have to do this, but if you want to add flair, go for it. And then I'm going to subtract these 2. 4 minus 9 gives me -5, and the b is now alone. Now that I have my b value, I can take it and the slope and put it together in my equation y equals mx plus b, which will be y equals 9/2 x minus 5. I put minus instead of plus because that b value we just got was negative. Okay, and there's my final answer. I know it doesn't look super pretty when we got to type it out, but we just got to do our best to make it look as nice as possible. Okay, standard form. Notice how I'm only giving you 1 for each type here. So before I was giving you 2 for parallel, 2 for parallel. Standard form, I'm only giving you 1. And that is because this is, in my opinion, the hardest type of problem, because you not only have to convert to standard form, but you got all these rules that you have to worry about. So maybe I'll insert a little text box up here as a reminder for standard form rules. Okay, let me just make this smaller here. So standard form reminders. Standard form is ax plus by equals c. Rule number 1 is that a, b, and c have to be integers. Rule number 2 is that a has to be positive. There's a third rule that says a and b can't be 0 at the same time, but we don't worry about that. You're never going to have to worry about that for the problems I give you. The third reminder is not really a rule, but really just how you're going to go about doing these types of problems. My suggestion is start in point slope form and convert to standard. That's my suggestion, okay? So to start, I'm going to write it in point slope form, which is this, y minus y1 equals x, or excuse me, in parentheses, x minus x1. And then I'm going to convert that equation into standard form, okay? So point slope, I'm going to write y minus the y value, which is 1, equals, and then up here, my slope that I want, I need to use the same slope, the original slope, because it's parallel. The original slope is 4, so that's what I'm going to type here. Open parentheses, x minus the x value, which is -1. So in my next step, I'm actually going to simplify that by making it a plus. If you want to go ahead and make it a plus right away, you can do that. You don't have to write this step followed by the plus sign. I just like to show it to show how I'm getting the signs. Okay, so far so good. Now, I need to make sure that I convert this point slope equation into standard form. Well, if I look at standard form, there's no parentheses, so I got to get rid of those. To do that, I simply distribute the 4. I multiply. 4 times x is 4x. 4 times 1 is 4. Parentheses are gone. Next thing I need to do is I need to move some terms around. I need the x and the y together and the constant by itself. Well, I've got a constant here on the left. I don't want that, so I'm going to move that over to the right by adding 1 to both sides. I'm going to be left with y equals 4x plus 5 when I combine those. Now I need to get the x over to where the y is. To get it over to where the y is, I look at the sign. It's positive, so I'm going to subtract it to move it, and I do it to both sides. And if you want to show that things are canceling out, you can do that. You don't have to. Okay, so I can't combine these two. All I can do is write them next to each other. So I've got a -4x, I have a positive y. I know it's got to be positive because there's nothing to the left of it. And then on the right, I have an equals 5. So it looks like it's in standard form, but again, refer back to these rules. The a value has to be positive. All of these numbers are integers, but not everything is positive. This a value can't stay a negative. So what I'm going to do is I'm going to multiply all terms by a -1, and that'll cancel out the negative for the a value. So I'm going to get positive 4x minus y equals -5. So basically just flip the signs of all the terms. Here is my final answer down at the bottom. It's in standard form. It's parallel because when I started, I used the same slope, and it follows all the rules for standard form where a, b, and c are integers and a is positive. All right, page 2. All of these equations are going to be perpendicular. So unlike parallel, perpendicular slopes need to be opposite reciprocals. So the first thing that I'm actually going to do here is determine what my original slope is. My original slope for this equation is -5. And if it's not a fraction, I highly encourage you to put it over a 1 and make it a fraction because we need the reciprocal. If I want the opposite, I'm going to make it a positive. If I want the reciprocal, I'm going to flip it upside down. So the slope that I want is going to be a positive 1/5. So I change the sign and I change the position of the numbers. So this is the slope that I'm going to want to use for my equation if it's going to be perpendicular. Next thing I need to do is I need to write my equation in point-slope form. Well, point-slope form is this: y minus y1 equals m parentheses x minus x1. Once you've got the appropriate slope, point slope is easy. You just plug everything in. So it's going to be y minus the y value, which is 0, equals positive 1/5, open parentheses, x minus the x value, which is negative 2. All I'll do in my next step is simplify those double negatives. You could even omit the 0 here too if you wanted to. I'm going to leave it though. Oops, not 5. It's got to be 2. There we go. Here's my final answer. So I guess I'll list it off to the side. You can say, or y equals 1/5 parentheses x plus 2. You definitely need the parentheses here though, because you've got a slope of 1/5. The only time you can omit the parentheses in point slope is if your slope is 1. Okay, let's try another one. Passing through this point perpendicular to this equation. Well, what's my original slope? It's negative 3/2. I want a perpendicular slope to that, which means I don't want a negative slope, I want a positive. And I don't want a slope of 3/2, I want a slope of 2/3. So here's the slope that I want to use for my equation. I also want it to be in point slope form again, so y minus y1 equals m parentheses x minus x1. So I'm going to take that equation and plug everything in. Y minus negative 1 is my y value, whoops, equals positive 2/3 is the slope that I want, parentheses, x minus 3 is my x value. Only thing to simplify here, double negatives. Always simplify your double negatives. Here we go. Here's my final answer. Okay, whoops. Slope-intercept form. So slope-intercept form, again, is y equals mx plus b. I'm going to start by determining what slope I need, though. Again, identify your original slope. Your original slope is this, 1/5. I want, if it's perpendicular, not the same slope, but an opposite reciprocal. So I'm going to make my slope negative 5/1, or just negative 5. If your slope is over 1, you can omit this part. It's just understood to be negative 5, okay? I think it makes the math a little bit easier when your slope's reduced to integers like this. All right, now slope-intercept form is y equals mx plus b, and just like on page 1, we're going to ignore the original b value. We need to solve for what our specific b value is going to be because it's passing through a specific point. So I'm going to substitute 4 for y, negative 5 for x, or excuse me, negative 5 for m, negative 1 for x, and again, we're multiplying, so I'm going to put it in parentheses, at least one of the values, and the plus b is a variable. Don't use this y-intercept up here. Don't use the original. Ignore it. Pretend it doesn't even exist when you're doing your problem. We're solving for a specific one. I'm going to simplify. 4 equals 2 negatives when I multiply gives me a positive. Oops. And then to get the b alone, I'm going to have to move this positive 5 by subtracting it from both sides. These are going to cancel. And then on the left, 4 minus 5 gives me negative 1. There's my b value, so I plug everything in to my equation. Everything meaning the b value and the slope. Y and x in your final answer should just be variables. So it should be y equals negative 5 x minus 1. There's my final answer. These two lines are perpendicular to each other. And if you remember, perpendicular means that when they intersect, They make a 90-degree angle. Okay. Same thing for number 9. I want it to pass through this point, perpendicular to this equation, needs to be in slope-intercept form. First, I'm going to identify my original slope. My original slope was negative 2/3. I want the opposite reciprocal to that. So instead of negative, I'm going to make it positive, and instead of 2/3, it's going to be 3/2. There's the slope that I want. And again, I want it in slope-intercept form, which is y equals mx plus b. I'm going to move this down here. And just like last time, I got to solve for the b value. The y value gets replaced with 2, y value from the point, equals m gets replaced with 3/2, x gets replaced with the x value of 2, b is a variable that I'm solving for. Again, I encourage you to use a calculator here or write it out on paper a little bit neater so you can see that these 2's are actually going to cancel out, right? This 2 is a denominator. If I make this 2 a fraction, this 2 is a numerator. They're in opposite locations, so they cancel. That's going to leave you with 3. To solve for b, I need to move this 3. It's positive, so I'm going to subtract it to both sides. These are going to cancel. 2 minus 3. Oh, look, I get another -1. That was a coincidence. I didn't mean for them to work out the same, but they do. And then last but not least, I'm going to substitute b and m in my equation. Y equals 3/2 x minus 1. Here's my final answer. And now for the hardest one. Again, I'm going to take this little text box that I put here and make it a reminder on this page, just so you have it. Standard form, I want it to be perpendicular to this equation. I want it to pass through this point, and I want it to be in standard form. Well, first things first, what's my original slope? My original slope is -1/7. I want a slope that's perpendicular, meaning I want the opposite sign, so positive, and flip the numbers around. So instead of 1/7, it's 7/1, or in other words, just 7. This is going to be easier to work with, so I'm going to leave it as an integer. Anytime you get a slope that works out as a nice integer over 1, just exclude the over 1 part. It'll just be easier to look at. All right, so to start, I want to write it in point slope form, which is this. Y minus y1 equals m parentheses x minus x1. And I'm going to substitute what I know. I know that the y value is 5. I know that the slope I need to use is 7, and I know the x value is 0. Now I need to convert it to standard form. So to do that, I need to get rid of the parentheses by distributing. So 7 times x gives me 7x. 7 times 0 gives me 0. So I don't even need to write that. I could if I wanted to. I could write plus 0 or minus 0. It really doesn't matter because 0 actually doesn't have a sign. So this symbol that I'm putting here in front is arbitrary. All right, so now I need to get the constant over to the right. The c value is the constant. To do that, I'm going to add 5 to both sides. Add 5 to both sides. These are going to cancel. And I'm going to get y equals 7x. 0 plus 5 is just going to be positive 5, even if this was a -0, right? 0, regardless of what symbol is in front, this is going to be your answer, whatever that number is that you're adding or subtracting. Okay, now I need to get the x term over to the left. It's positive, so I want to subtract it from both sides. These are going to cancel. And I can't combine these. All I can do is put them next to each other. So that's what I'm going to do. -7x, y doesn't have a sign in front, so it's positive, equals, and all I have left on the right is a 5. All right. A, B, and C have to be integers. They are. A has to be positive. Oh no, so I got to clear this negative. So I got to multiply everything by -1. If it was a fraction, you'd have to clear the fraction by using the LCD method. Let me move these a little closer. kind of hard to do this typing it out, but that's okay. All right, first product is going to be positive 7x. Second product is going to change the sign to a negative y. And last product is going to change that positive 5 to a negative 5. There is my final answer. It's in standard form. They're all integers. A is positive, and it's perpendicular to the original equation because I changed the slope to be the opposite reciprocal. So I hope this review comes in handy. As is usual, if you run into any problems, if you're confused, leave comments on the video, leave messages or comments on Google Classroom, or email me. Your review again will be due Wednesday, quiz on Friday. Take care.